Hi, this is just a quick video just to discuss how to do pressure drop calculations using the Dolomite website. So if you go to applications and application notes, come down to the bottom, we've got a microfluidic calculator. Alright, so what I'm going to do is just click along. First of all, I just want to say that we have fluidic pressure resistors on our web store, and I also want to say that we also give you a kit to make your own custom pressure flow resistors. So just to kind of say, if I go to our web shop and I just put in the keyword resistor, it comes back with the custom flow resistor kit, and it also comes back with a whole series of flow resistors. So I just want to kind of say that, but I'm going to get back now to the main part of this, which is calculating pressure drops. So application notes, that calculator. Because what I'm going to say in this note is, it's really a follow-up to a previous one where I kind of say, if you want to have a very small pressure applied to a sample, then you need to put a pressure resistor in that fluidic setup. And this is how to calculate the kind of pressure associated with that pressure resistor. So let's just go next. So most of our pressure resistors or resistors to flow are circular in nature. So I'll choose circular. I'm going to say to you that our custom kit has a 100 micron diameter, and I'm going to sort of take a guess that we'll use 500 millimeters length on that. You can obviously just kind of not screw it up on itself, but sort of wrap it up so it's not so long and dangling around. So 100 microns, 500 millimeters long. I'm going to use this selection because I just want to talk about flow rates. So I'm just going to select here and go next. So the water is, or rather the solution is water, and I'm going to say 2 microliters, which is definitely one of our flow sensors, and I'll touch on that in a minute. So 2 microliters, and I'll hit next. So what this is telling me is, if I have a tube that is 500 millimeters long with 0.1 millimeters or 100 microns in diameter, then the pressure drop across it is about 68 millibar, which means if you apply 69 millibar, your sample, 69 millibar from the pump, your sample's actually only going to see 1 millibar. Or if you apply 78 millibar, then your sample is actually only going to see 10 millibar because you've dropped most of the pressure across this resistor. So this calculator is a way of calculating how much pressure your sample is really seeing. And this is really kind of complementing a video earlier on. So I'll just kind of go through it again. I know I'm stating the obvious. I'll do a slightly different calculation this time. So what we'll do is, we'll say it's circular. We'll say that you put a meter there. Let's choose water. Alright, we'll stick with the 2 microliters for now. This could also be 0.6 microliters, whatever. And it tells you that the pressure drop now is 136 millibar. So again, if you apply 137 millibar from the P-pub, the sample's actually only going to see 1 millibar. If you apply 147, then the sample will see about 10 millibar. So this is just a way of you knowing how to drop the pressure in order that your sample sees a much lower pressure than the pressure you're actually applying. Okay, thanks very much.